G'day everyone, back again here. This is still the 30th of March. Lots of videos today, so if you see my shirt doesn't change much, trust me, I do shower and I do change my shirt, but 10 videos in a day, you're going to be stuck in this kit. So, what are we doing now? We're on inverse functions. So, the next part of our specialist course is inverse functions. Now, this is what we're talking about when we're talking about an inverse function. We put a -1 just up here. So, this would be the original. This would be the inverse of the function. Now I make this note here, and please be aware of this, that f to the -1 of x is not the same as brackets f of x minus 1. This one here is the reciprocal, okay? That there means that we're going to do 1 over f of x, and that's not what we're doing, okay? What we're doing is the inverse, which is effectively taking the x and making it the y, and the y and making it the x. So just be aware, this completely different to this. So what do we do? Let's start with an example here, 2x plus 3. Nice simple linear equation. Now what we're going to do is we're going to swap the x and the y over. That's what inverse is about, swap the two over. So swapping the two over, can you see how I put an x where the y was and a y where the x is? I then rearrange to get it back into y equals, because I'm kind of familiar in this y equals format. So here's the original, here's the inverse. I'm going to write that in a slightly different way to what's there. I'm going to call this f of x, 2x plus 3. And then this one, I'm going to call f the -1 of x, okay? And we're going to write it slightly differently to here. I'm going to write x over 2 minus 3 over 2. Just so it's in my y equals mx plus c format. Let's graph them up. First one, 2x plus 3. I'm going to put 3 right there, and 2x means it's going to have a steeper gradient, 1.5 there. So I reckon it's going to be something like that. Y equals 2x plus 3. Hopefully you agree. I think I'm okay on that. So 3 here, and this would be minus 1.5 or minus 3 over 2. We could do a double check, put 3 over 2 into there. We'd be left with a -3, plus 3 would be 0. That's correct, it's the x-intercept. So I think I'm okay there. This one now, -3 over 2, that's the y value. So that would be equivalent to there, but on this axis. So that would be about there. And the gradient here is a half. Gradient's a half. So that's a gradient of 2. Gradient of 1 would be there. Gradient of half is going to be something like that. Okay, something like that. So I reckon, well, let's get our x-intercept happening. When y is equal to 0, let's just solve that. Move that guy over. We'd have 3 over 2 equals x over 2. Cancel those two. X is going to be 3, isn't it? So that means here, well, we're seeing something here. 3 I'm going to put there. So I end up with something like that, okay? And then when I connect this line, oh, that's not too bad, I didn't do so well there. There we go, that's better. So hopefully you can see that, the black pen's not so good. This one here, let me make it in red. That's better. You get the idea. This one is going to be y equals x over 2 minus 3 over 2. Now that means that this is really f to the -1 of x. And this really is f of x. Okay? Now, that's the idea of inverse functions. But we want to be a bit better than that. We don't want to just go, oh, I have to graph them every time. Have a look at this. If I draw a dashed line, I can actually show you what's going to happen to any function without actually having to do the number crunching. Sometimes that gets difficult. If I draw a line here at 45 degrees, can you see how the original function has been reflected over the line of y equals x? So the original function has been reflected over the line y equals x. So that means that in the original one, any point that lies on the line of y equals x, this point right here, doesn't change. So if you were given a function and you really didn't know what the original equation was, you can still do this because you just pick any point on y equals x. So, well, that doesn't move, and the other bits of the function have to flip over that. Okay? Let's recap. So inverse functions, it's not reciprocal. Reciprocal is a different thing. Inverse function is swapping your x and your y over to get a new function. Those two functions, your original and your inverse function, will reflect over the line y equals x, meaning that if you see something here, 3 becomes 3. Because look, here's the idea. This point here, isn't this 0, 3? 0, 3. Well, when we flip it over, when we flip the x and y over, or we flip over this line, doesn't that just become 3, 0? See how they just flipped over? This point here, that would be what? 0, negative 3 on 2. This point here, isn't that point negative 3 on 2? Oops. 0? Hasn't that just flipped over? And isn't that going to work with every single point? Well, it is. Pick any point you like, and you'll find the equivalent point over here is just those two numbers flipped over, because that's what we're doing here. Okay? So hopefully this has helped. This is not a big section. It's not likely to be examined strongly. But if a question comes up, you're going to want to know about it. So review this, do a couple of questions, make sure you're okay with it. These sort of questions can be built into composite function questions. So you might be asked to find a composite function and then find the inverse of it. So there is an opportunity to meld 2 or 3 points in the one question. Hopefully this one's helped. Catch you later, guys.